Alright, today we are going to review segment addition postulate and midpoint. So our first step in solving a geometry problem is to make sure our diagram is completely labeled and filled out. So remember, this is segment addition postulate, so we're looking for two segments, two pieces that we can add together equaling a total. And some information they've given us here, they've told us segment DE, EF, and they've told us the total for DF is 42. So I'm going to make sure I have that labeled. Second, I need my segment addition postulate, my geometric statement. So that is actually labeling DE plus EF equals DF. And remember, we like to write off our reasoning off to the side, and this is going to help us later on when we are solving for two-column proofs. So I can write this geometric statement because of the segment addition postulate. That's my proof. Now I will plug in the expressions given to me, and then I solve it algebraically. Okay, so solving algebraically, combining like terms on the left side, 7, so I get 11x, adding my constants here. Remember, take the sign in front so you know if it's positive or negative. So this is plus 1 minus 3, which gives me a negative 2. If you are struggling on this third step on, okay, I just don't know where to begin, then remember, get your x's on one side, your numbers on the other. This is, so left for your x's, right for your numbers. This is not a rule in math or in algebra that you have to have, but if you're struggling like I did when I was in school and I just didn't know where to begin, this is where you begin. So no more giving yourself too many options that you just don't know where to begin. Get your letters on the left, your numbers on the right. Now for those of you who are confident and you've already figured this out, you can work these out however you want. Rearranging doesn't really matter. You do your thing. But again, for those of you who are struggling and you're just tired of getting this algebra stuff wrong, get your x on the left, your numbers on the right. It's going to work for you every single time. Trust me. Okay, so now you'll notice I've got my x is already on the left. So what's got to go is that loner 2. Call that loner. He's our constant. And now I am down to my one step, which divide both sides by 11. X equals 4. Okay. Now this is where I also struggle because I get caught up on my algebra and I'm like, oh, okay, x equals a number, I'm good, I'm done. And then I'm like, well, wait a minute, that's not what they were asking for. So in geometry, we always have to slow down, look, okay, are they asking us to solve for x, or are they asking us to solve for a little bit more? And so they are actually asking for the length of segment DE, which they've told us, and I forgot to color code. So I have found, when I'm looking for my pieces here, if I color code my segments, I don't know, just for me, it helps it stick out just a little bit. And I realized when I went to write DE, I was like, wait a minute, which one of those is DE? So color coding helps. DE is this turquoise color that I'm using, and that is 7x plus 1, but instead of x, I will replace it with my 4, and we find segment DE is 29 units. They don't give us the units, so I'm not stressing too much about that, but there it is. Okay. So let's go ahead and look at number 10 as well. This is going to be a little bit of a long video, but I am going to be working out 5 problems with you. This is your review for those that are in my classroom. So, you know, spend the time going over this. Make sure you come to me tomorrow with questions if you have it before you take your test. All right. So again, first thing, I need to make sure that my diagram is completely filled out with all the information given to me. And they have told me that JL, segment JL is this whole thing, this entire thing, is 10x minus 2. JK is 5x minus 8. So I'm going to go ahead and label it right on that segment. Don't be afraid to write on our diagrams. And segment KL is 7x minus 12. And I know some of you are thinking, like, that is not a length. That is the craziest looking lengths I've ever seen. So I mean, this is where we can kind of see our algebra coming into play here, and we're like, okay, I think I'm going to have to find x before I can go ahead and solve and find an actual measurement, right? I've never measured something as like, okay, the length of my fence is 10x minus 2, right? That doesn't make sense. Right now, it doesn't make sense because I don't know what my x is, but it will once I find that. So our goal is solve for x first. I have my diagram filled out. Second step, segment addition postulate. I want to write that geometric statement. My proof for it is supported by segment addition postulate. So I know JK plus KL equals JL. Now remember, we're looking for a piece plus a piece equaling the whole segment. So let me go ahead and color code. Just kind of, it gives me that visual aid that I need to see the pieces. I struggle with it sometimes as well. So, you know, use a highlighter, use colored pencils, whatever is going to make your life easier. Once I have my diagram labeled, my geometric statement, now moving on to my algebraic statement. Okay. So if you are confident at this stage, you razzle-dazzle me with all that beautiful algebra. If you struggle with this, which is fine, I've always been honest that I struggled with that too. Remember, get x on the left-hand side, your numbers on the right. And I am going to go ahead and combine like terms here. Because my x's are already on the left. Uh-oh, I see one on the right. So my brain's already telling me I'm going to have to move it over. So combine like terms first. There's no distributing here. So x's with x's. And I get 12x. Negative 8 minus 12. So you see where I'm always very careful that I am including the sign in front. So I know if I'm adding or subtracting, dealing with positives or negatives. So if I have 8 negatives, I have 12 more negatives. That is 20 negatives total. So this one's going to have a few more steps than number 9 because I am going to have to move two things. I'm going to have to get this x over here with the 12, and I've got to get this 20 over there with the 2. X's with x's, numbers with numbers. And again, moving them to the left. So sorry, I'm going to squeeze that in there. So negative 10x for both sides. I'm going to go ahead and add 20 here. If you're okay doing both of those steps at once, squeeze that in there to this worksheet. Cancel my opposite signs. And what I'm left with on the left side is 12 minus 10 is 2x. On the right side, negative 2 plus 20 is 18. Use your calculator if you're struggling with those integers. Divide both sides by 2. X equals 9. Okay. So I always have to ask myself, because I'm used to my algebra, x equals a number, I'm good. But in this case, it was not asking for just x. We're needing to know the segment length of segment KL, excuse me. So KL, going back over here, KL is this yellow section right here. So it's 7x minus 12, but instead of x, I'm going to replace my x with a 9, which this substitution skill comes in handy next year for Algebra 2. So if you're struggling with this, let's get you some help. Come see me. And what do we get? 7 and 9 is 63. 63 minus 9 is 54. Ooh, I think I might have messed up. So, oh, it's 12. Look, got to write the problem down right? So 12 and 63 minus 12 is 51. Ooh, sorry for the sloppiness there, but it happens to us all. Sometimes we write down the wrong number. Our strategies are right, it's just a silly math mistake. Okay? All right, here we go. Looking at number 11. Oh, I see a clue word there, you guys. Midpoint. If you remember, midpoint means middle. We have a point that's being, that's cutting a segment down the center. Okay, and there's no diagram. There's no diagram on this one. So my first step is I need to draw that. So if S is the midpoint of segment RT, let me get my protractor here. What did I do with them? Sorry, on a straight line. I've got my straight edge, and its segment RT is being has a midpoint of S. Now I'm not really measuring that, so I will go ahead and I'm going to go ahead and put my congruency marks there for right now. But just by using the word midpoint, they're telling us that these are two equal segments. Okay, so we didn't even have to have the congruency marks. Just by using that vocabulary term tells us that they should be the same. And now that I have my expressions, my brain stopped for a minute, I can go ahead and fill out the rest. So RS, I'm going to go ahead and color code again. RS plus ST, remember looking piece by piece equaling a total. Okay, so I know that RS is 5x plus 17 because they gave that to me right here. And ST is 8x minus 31. Again, that is given. So if this was a two-column proof, we could say given. That could be our justification. All right, this time, when I go to write my geometric statement, it is not a segment addition. This is by definition of midpoint. And so that is my proof that I can say segment S is equal to segment ST. That is my proof. So if I was doing a two-column proof, I had RS plus ST on the left side. My right column, my reasoning would be definition of midpoint. And again, we're reviewing this just to make it easier on us later on in the year when we get to two-column proofs. Okay, 5x plus 17 equals 8x minus 31. Okay, my goal, get letters on the left, numbers on the right. So I will subtract 17, keep numbers with numbers, letters with letters. Subtract negative 8x. Cross out the ones that are opposite signs. And I get negative 3x equals negative 48. Divide both sides by negative 3. And I get positive 16 is my x. Now I'm going to pause. Were they asking us to find x? No, they were asking us to find segment RS. And you'll notice the more we progress through our geometry, it's no more just finding x. It's find x and then plug it in to something else, which again is a good skill for Algebra 2 next year. Okay, segment RS is this piece right here that's the turquoise piece. So you see I did not have to use the segment addition postulate today or on number 11, but sometimes we have to, so I'm always reviewing that. Whoops, instead of x, let's put our 16. I'm just going to keep making sloppy mistakes on this today. I apologize. And 8 times 16 plus 17, you can put that in your handy-dandy calculator, and you get 97. So RS is 97, which would make more sense if I was like, okay, I need 97 feet of fencing. Makes more sense than I need 5x plus 17 feet of fencing. Okay. All right, here we go. If line Y bisects, there's another vocabulary word they threw at you. If you remember, bisect means that it cuts the segment in half. So if it's a point that's in the middle, we call it midpoint. If it's a line, a ray, another segment, we call it a segment bisector. And so if Y bisects AC, that means that these two are equal to each other. And they've given us AB segment AB is 4 minus 5x, and BC is 2x plus 25, and then we will find AC. We got to get rid of those x's because, again, 2x plus 25, that's a weird measurement. It's not going to help you if you go to Home Depot and you're like, oh, I need 2x plus 25 feet of fence. They're going to think you're crazy. So AC has been cut down the center. Everything that has been given to me is labeled on my diagram, so my first step is done. My geometric statement would be segment AB is equal to segment BC, and this is definition of bisect, or I would say segment bisector. And I'm just abbreviating this. We'll be more specific. I can't spell. We'll be more specific when we get in there. I just want short little notes off to the side just to get our brains using that word. And I know it sounds really wordy and lengthy because I'm like, AB equals BC by definition of segment bisector. And that's okay, because that's what geometry is all about. Proof, proof, proof. Okay, now I can go ahead and set up my algebraic statement. 4 minus 5x is equal to 2x plus 25. Okay, now we're going to work our math magic here. Get our letters on the left, our numbers on the right. And again, that's not a rule. You can have your letters on the right and your numbers on the left. This is for those of us who are just trying to survive here and get this right. Okay, x equals -3. So you might panic a little bit if you come across a negative here. Say, well, I haven't been seeing negatives. It is perfectly fine for x to be a negative. It's our distance, our lengths, that we don't want to have negative, right? We can't have, I have a stick that's -3 feet long. No, absolute value distance is always positive, but it's okay for x to be negative, okay? So they're wanting us to find AC. AC is the entire thing. So here we go. That's segment addition postulate. Showing back up. It's always sneaking in here. Once we learn these things, they keep coming back around. So I know AC is AB plus BC. And since this is our kind of our beginning lessons, I'm going to go ahead and use this segment addition postulate. Some of you might have already figured out I just need to find this length and then double it because it's the same. It's up to you on how confident you are and what you want to do here. So if I plug in, I'm going to go ahead and do it over here. Let's see how well we do with that. Placing with a -3, and that would be 4 plus 15 is 19. And so that means that this one should also be 19. So 19 plus 19 is 38. Okay. If you don't like what I just did off to the side, you feel free to go ahead and use your segment addition postulate like you've been setting up your expressions, then your equations and solving. Okay. You really do what you're most comfortable with. But if you're okay, doing a little work off to the side and then coming back around, feel free to do so, whatever you're comfortable with. Okay, here we go. Moving on. If B is the midpoint, telling me that's in the middle, I'm going to go ahead and just mark that right now so I know it, that those two are the same. From AC, AC is equal to CD. So let me go ahead and color code this. So I know I have two segments here that are the same. They also told me AC is the same as CD. All right, let me go ahead and start labeling now. So I've checked this one, I've gotten this one written down, and now AB is 3x plus 4. AC is this whole thing. I got that one. AC is 11x minus 17. And CE, which is this entire thing, they like to give you pieces, right, is 49. So I believe I have everything labeled, and I'm going to be solving for that guy right there. Okay, well, let me see if I can move my face out of your way here. Okay, so I know I got to get rid of x, right? We know that that doesn't make sense when we're talking about measures. So let me go ahead and use this is my first one, it's all set up. I'm going to use my segment addition postulate. That's going to allow me to say that AB plus BC equals AC. So I need to get rid of that. So AB is 3x plus 4. Uh-oh, but they haven't given me BC. Well, they really have. They just didn't type it out here. But they told you what BC is by using the word midpoint, because that means it's been cut in the middle. So I can actually label that 3x plus 4 as well. Or you can times it by 2, whatever you feel most confident with. And then I know AC is 11x minus 17. Okay, so again, we talk about that in my class, that in geometry, they can tell you information by just using a vocabulary term. okay? So, and that's where it gets a little confusing, and we have to spend a lot of time, you know, reassuring ourselves, okay, this is what midpoint is, this is what bisector means, and we'll constantly review those, okay? Now we're just using our math skills, our algebra skills here. We get 6x plus 8 equals 11x minus 17. Always combine like terms. And then numbers on the left, letters on, oh, I said it backwards. Letters on the left, numbers on the right. And we get, what, negative 5x equals negative 25. Divide both sides by negative 5. So it's okay for it to be a negative. Don't stress over that. And we get 5. So x is 5. Okay, so how am I going to use that to find the segment DE? Okay, well, do I know what CD is? Because I know we're always looking for a part plus a part equals a whole. Well, I know I'm missing this part. I know the whole. So they did. Remember, I color-coded that for some reason. So if I look back here, it says AC, this is where it came from, AC is equal to CD. Remember, equals means we're talking about the numbers, so I can actually put the exact same expression for CD that I did for AC. So now, DE, I'm going to use segment addition postulate again. That one just keeps coming back around. So I can say CD plus DE equals 49. CD is 11, but instead of x, I'm going to go ahead and substitute my 5 minus 17 plus DE equals 49. All right, now just work out my algebra. I get 55 minus 17 plus DE. I know it looks crazy, but go ahead and leave DE. That would be like our x. We're solving for a variable. 55 minus 17. And then subtract from, there we go, let me do some math here. 55 minus 17 is 38. I skipped that step on my notes, so I'm going to show all my steps here. Subtracting 38, and segment DE is 11. All right, make sure you keep practicing this and let me know if you have any questions.